Hello, good to see you again. Welcome to the start of Year 7, Term 2. So we'll start with Block 1, Lesson 1. And the title for Block 1 is Solving Problems with Addition and Subtraction. I'll share my screen. So in today's lesson, you're going to learn about properties of addition and subtraction. It is very important to pay close attention to properties of addition and subtraction and things we call facts, uh, addition and subtraction facts and how to work with them, because it's going to really help you in building a solid foundation in your understanding of mathematics. But before we start, I would like to appeal to you to like the videos, um, share the videos to those you think will find the videos helpful, and subscribe to the channel to help us in our mission to educate the global population of children who may not have access to high quality maths education. Thank you. Before we start, I would like you to answer these retrieval practice questions in 2 minutes. All right, assuming you've paused the video and you've worked through these questions, here are the answers. Let's discuss them. For the first one, you were asked to work out the missing number in each representation. So this is the bar model, and we know that for the bar model, we always add the bars. So here is 9 plus 17, which will give us 26. This is a part whole model. And for the part whole model, the numbers at the bottom of the part whole model are added to get the numbers at the top, a bit like an inverted tree. So we know that 12 add 4 is 16. So the missing number has to be 3, because to get 19, we have to add 3 to 16. Another way of thinking about it is to say, well, if I'm going to have to add everything at the bottom of the tree to get 19 at the top of the part whole model, then I can do 19 minus 12 plus 4. Yeah? Okay. So I should have talked about this one. So B, we add 12 and 28 to get 40. So that's for 1B. So 1C is what I was talking about. So that is the answer. And then for this one, we're asked what number should be here such that this number line, should be correct. So another way of thinking about it is to say, well, if I have to add 10 to a number to get to 22, well, I can do the inverse operation, which is 22 subtract 10 to give me what that number is, and that number has to be 12. Let's do some new learning. Here, 15 add 19 is 34. How would we represent this in a bar model? Of course, by now you should know that for the bar models, we add the bars. So we write 15 as one bar, 19 as another bar, and another bar for 34, which shows that 19 plus 15 is 34. We can also represent this as a part whole model. So we write 2 circles, 15 and 19, and they should add up to give us 34. We could also represent it in the number line form, where we write 15, we add 19 to get to 34. Okay. Could we also write it like that? Of course we can. Why? Because addition is commutative. Commutative means that we can change the order in which we write the numbers, we'll get the same answer. But what else can you notice? You can also notice that we can write this as another fact of this calculation by saying, well, 34 minus 15 will give us 19, or 34 minus 19 will give us 15. All right. What we've learned so far is that you can use in learning making use of the properties of addition. Remember, our title is properties of addition and subtraction. We can use the facts that we know about addition and the different ways we can represent addition to find the inverse of a calculation, just like we did 34 subtract 19 and 34 subtract 15, which gives us 19. Okay, pause the video. It's time for you to practice for this first part of the lesson. So pause the video and answer questions 1 and 2 in 3 minutes. All right. Assuming you've paused the video and you've answered questions 1 and 2, here are the answers. You can mark your work and celebrate your success. For question 1, you were asked which calculations are represented by the bar model. Tick your answers. So you can see that is represented by that calculation. This one as well, because imagine taking a slice of that from the 58 bar. So that is like saying 58 subtract 35, which will be left with 23. And that calculation is also equal to, you can represent that with the bar model. So you can say 23 is equal to 58 minus 35. Okay. You can also represent it like this. Okay. 58 is equal to 35 plus 23. And then here you're asked to write 2 additions and 2 subtractions represented by the part-whole model. And you should see we can write it in different ways. It's important that you know how we work with these, because when we start to talk about in year 8, more difficult aspects of addition and subtraction, even involving algebra, this method or this idea of knowing that you can write different facts of the same calculation will be very helpful. Pause the video and answer questions 3 and 4 in 3 minutes. Assuming you've paused the video and you've answered questions 3 and 4, here are the answers. Let's discuss them. For question 3, you were asked to complete the additions and subtractions represented by the number line. Here, it's showing that 74 add 56 will give us 130. And we can also represent the calculation like this. We can also represent the calculation like this and like this. So these are all different facts of the same calculation. Here, this shows subtraction. So we can write this like this. 139 add 62 will give us 201, and we can write it in a commutative form. So that's commutative. Both of them are commutative. So regardless of the order we write it, we'll get the same answer. Here, we can see the results of different ways of writing the same calculation. Pause the video and answer question 5 in 1 minute. All right, assuming you've paused the video and you've answered question 5, here are the answers. Let's discuss them. So here we were asked to draw a bar model, part-whole model, and number line to represent the calculation 114 subtract 56 equal to 58. Okay, you can see that's the number line form, that's the bar model, and that's the part-whole model. Well done for answering and practicing the questions for the first part of the lesson. Let's do some new learning. If we have this calculation, what do you notice? Well, you can see that this is an example of having commutative representation of the same calculation. So the order in which we write this calculation does not affect the result. What about this one? We know by now how to represent the calculation using a number line. So 15 add 19 is equal to 34. And we can represent the same calculation as 34 subtract 19 is equal to 15. But is 19 subtract 34 equal to 15? Do you think we can do the same thing we did with addition by thinking, okay, I can swap the calculation and still get the same answer? Will it work for subtraction? Well, we're going to disagree with this young man. Why? Because we know that 19 subtract 4 is equal to 15. So it's obviously not true that 19 subtract 34 will be equal to 15. So we're going to disagree because we know that 19 subtract 4 is 15. So they cannot be right. How would we represent this calculation? Have a think. Well, we know that we always add the bars in the bar model. So what we're going to do here is we can write the calculation like this. So we know we're adding these. So 40 add 52 add 20 is equal to 112. We can also rewrite the calculation like this because we can write different facts from this same calculation. So we can say, well, 52 add 40 plus 20 is 112. So remember, addition is commutative. We can also write it like this. If I drew a line across that point, what calculation can you see here? Imagine that we take a slice of the bar of 20 off the bar of 112. What calculation would you represent? Well, we can say 52 plus 40 is equal to 112 minus 20. Can you see any other calculation? Of course I do. We can have 52 add 20 plus 40 is equal to 112. Do you see on the other calculations? These are all facts, remember? These are all facts of the same calculation. We can also write that. How would you represent this one? Where would you draw the line in the bar model to show this calculation? That's right here. 112 minus 40 is 52 add 20. I think there is one more calculation that you may not have spotted, but it is quite obvious. Well, here it is. 152 subtract 112 subtract 52 will be equal to 20 add 40. Okay, so far we have learned in the second part of the lesson that you can represent the same calculation using different facts about the properties of addition and subtraction. It's now time for you to practice what you've learned. Pause the video and answer questions 6 and 7 in 3 minutes. Assuming you've paused the video and you've answered questions 6 and 7, here are the answers. Let's discuss them. Here you were asked which calculations are represented by the bar model. Of course, you can see the calculations that are represented by the bar model. So by now, you should know how to interpret bar models. Next, question 7. You were asked, this bar model shows that addition is commutative. Addition can be calculated in any, so you're asked to explain what it means. Addition can be calculated in any order, so it can be written like this or like that. And you can see that the bars are of the same length. Pause the video and answer questions 8 and 9 in 3 minutes. Assuming you've paused the video and you've answered questions 8 and 9, here are the answers. Let's discuss them. Here, question 8, you were asked to explain why Eva is wrong. So Eva said, I know 60 subtract 14 is equal to 46. So that means 14 subtract 60 is equal to 46 too. Why? Subtraction is not commutative. We cannot swap calculations around and have the answer being the same for subtraction, but addition is commutative. Question 9. Niger works out 57 plus 64 plus 43 like this. Why did Niger change the order of the numbers before adding them? Niger would have done this because she wanted to make the number bond of 100, hence make the calculation easier to work with. Next, write each of these additions in another order to make them easier. So you could have done it like this. You could have done it like this or like that. Pause the video and answer questions 10 and 11 in 2 minutes. Assuming you've paused the video and you've answered questions 10 and 11, here are the answers. Let's discuss them. Here you were asked to write 2 additions and 2 subtractions represented by the part-whole model. Now you can see that we can begin to use letters, which brings us to the concept of algebra. We're not doing that yet, but it's just to show you how this knowledge that you have gained about the properties of addition and subtraction can be generalized even in algebraic form. And here are the calculations. And this one, you were asked to show that these statements are always true. Of course, they are always true because you can use a bar model to represent these calculations. So what we have learned so far is that using the properties of addition and subtraction, you can begin to write different facts of addition and subtraction calculations and even generalize those facts to work with letters, which brings you to the area of algebra. Remember an important fact or 2 facts that we've learned. Addition is commutative. What does that mean? The order of the calculations does not affect our result. So for example, 1 plus 2 is equal to 3. 2 plus 1 is also equal to 3. Subtraction is not commutative. You cannot swap the calculations and expect to get the same result. For example, 2 minus 1 is equal to 1. 1 minus 2 is not equal to 1. Until next time, take care of yourself and bye-bye.